Welcome back to StartupHakk. I'm Spencer Thomason, and here at StartupHakk, we love to train software developers and build custom software solutions. I do a lot of work as a fractional CTO. With over a decade of executive leadership experience and a solid 25 years in software development, I've mastered the art of transforming technology, teams, and products. Today, we're diving into an exciting topic that's been a long time coming: Windows on ARM. Is it finally here? So let's dive in and find out. All right, so let's dive in and talk a little bit about Windows on ARM. Now, we've been talking about this for a long time. Now, why do we as developers or entrepreneurs care about Windows on ARM? Well, for starters, Apple's been beating us on with the Mac's M3 chips for quite a while now. And so when we get Windows on ARM and when it finally will come around, which it's been a long time coming, as we'll talk about here, we'll get better battery life, less power consumption, which just means like days of battery life, overall performance gains, plus some other bonuses that we're going to get from it that we'll talk about toward the end of the video. So let's dive in a little bit and talk about this. So I'm going to switch over to my full screen here. So we can see that there's a lot of noise being made about this, right? ARM is here to stay. Qualcomm, helps Microsoft with this. Will Windows on ARM PC finally be worth buying? And so I want to go through some of these, and there's a lot of actually interesting benchmarks, particularly in this one, but in all of them. And I want to talk a little bit about ARM and the journey of Windows on ARM a little bit here today. So one of the big things is that for years we've been hearing whispers and rumors about Windows running smoothly on ARM processors. Microsoft has made several different attempts, but every time they were far short of our expectations. So the promise of a seamless, power-efficient Windows experience on ARM has been exciting, but never delivered. So now with the latest advancements, it seems like we might finally see this come to fruition, which is super exciting. Microsoft launched ARM on Windows for ARM in 2012 with the Surface 2-in-1 powered by NVIDIA's Tegra 3. Now, it didn't catch on because the original Surface was so slow and buggy and ran on an ARM-only version of Windows called Windows RT. And it was really annoying when they did Windows RT because you had to have specific apps for Windows RT. Those apps were always really buggy. Developers had to compile differently. And so even like the .NET framework at first didn't really even work on Windows RT and took a while for it to catch up. It was a mess. So Microsoft finally retreated. They waved the flag and retreated. And then they started to release the Intel-powered Surface Pros. Now, the recent benchmarks have shown really impressive results, putting ARM Windows-based devices in competitive positions against traditional x86 and Apple's M chips, like the new M1, M2, M3s. So we're seeing improved performance metrics in areas such as battery life, efficiency, and even raw processing power. And they're adding some extra juice into it for some other things here that we'll talk about. These benchmarks highlight the potential of ARM architecture to revolutionize how we interact with a PC, and I'm going to go through some of those today. The Surface Laptop Pro 7 also includes, and this is what I was talking about, Copilot Plus PCs with the Snapdragon X chips. And it benefits from the advantage of ARM chips often hold compared to x86 efficiency. Laptops with a Snapdragon X can last over 20 hours on battery life, and they meet or beat x86 alternative performance benchmarks. So, and I'm going to show you some of these metrics here, and so let's dive into some of these before we go much further. But tests have shown that Snapdragon X is up to 50% more efficient than comparable x86 chips in a single-core workload and 20% more efficient in multi-core workload. So that translates not only to a long battery life, but also less heat, less fan noise, and better performance of the battery. But I want to kind of look into some of these here, and so we can see these new, I'm going to zoom that in a little bit. We can see that the new chips are really impressive looking, right? 12 core, and I know core hasn't always been one-to-one on x86s with ARM, but we're actually finally starting to see these really catch up, and like I read a minute ago, that we're seeing even the single core. So when it starts talking about a 12-core processor, it's actually starting to really stack up comparatively. We can see that the GPU is 4.6 teraflops, and 42 megs of total cache. So those are really impressive specs. So to put this in comparison, Apple's M3 is 8 cores, 4 performance cores, 4 efficiency cores, and 4 gigahertz clock. And so it gives also 10 GPU cores. Now, you can see how it compares up against some of these x86. And, the x86 are potentially going to be better in some of the performance benchmarks, but the trade-off for what you're getting for the efficiency is frequently not worth it. Now, I mean, if you're running some really heavy, processing, but even like for developers anymore, it used to be that you really needed this high-end system to be able to compile, but these new ARM systems are totally able to compile, and we're seeing that now. And so, we're talking a lot about some of these. So we can see where some of these start to come in, and you can see the, the Snapdragon 7. But the difference here is that while we have, single core benchmarks are, running, so we've got this one up here that's running, third from the top. And you can see that the MacBook is still, beating it slightly, but our efficiency gains here are huge. And so for those of us that don't really want to switch to Mac, sorry, I'm one of them, that really don't want to switch to Mac, this is really exciting because we're seeing some hardware that's coming out that could actually start to compete against some of these MacBooks for efficiency, meaning life of the battery and how long, and it's still powerful enough. I'm really excited by this one down here. I'm actually recording this on a Dell XPS 13 right now. It's an older 2021, so I've actually been looking to kind of upgrade. So I'm really eyeballing these really closely to look at this one, this XPS 13. I'm really interested in this. I was actually, as I was preparing for the live this morning, last night I was pricing one of these out. I almost never price out hardware. I'm one of these guys that like to see how far I can push hardware. But the benchmarks on these are really, really good. You can see that while they're just slightly behind the MacBooks, definitely efficiency-wise, right in the same ballpark. And so, exciting to see some of these comparisons here. And so it's going to be interesting to see how things continue to move forward. Qualcomm, Intel, and AMD are all playing significant roles in this transition. Qualcomm Snapdragon processors have been particularly noteworthy, pushing the boundaries of what's possible with ARM. Meanwhile, Intel and AMD aren't sitting idle. They're exploring ARM's potential in various different ways. This collaboration and competition are driving innovation at a pace that we've rarely seen. Now, one of the things I think is going to be really interesting about this is as we see Copilot being designed to work with these ARM processors, I'm interested to see how we can start to see the use of ARM in driving the power of AI. I think if we can continue to do that and get the dependency off of NVIDIA and get the dependency away from these really power-hungry GPUs, I'm going to be really excited to see some advancements of that. So it's one of the reasons I'm really excited about ARM is I'm kind of looking a little ways off. Wow, that was really close to the camera. Seeing some of these long ways off and seeing how this is going to affect AI as we move forward. So Microsoft has definitely shown a renewed commitment to making Windows on ARMs a reality. And they've been in this game for 12 years now. So this is pretty interesting to see that Microsoft's actually, really, I think this is an interesting move for Microsoft to really try to stick with this. So with better development tools, more robust support, and a clear roadmap, Microsoft is signaling that they're all in. This level of dedication is totally crucial for the platform's success. And so the success of Windows on ARM could herald a new era in computing. Imagine that devices are lighter, that they're more energy efficient, and just as powerful as their x86 counterparts. I'll even personally take a small trade-off in performance if I can get more power, more longer efficiency, more energy efficient, as well as cooler. My XPS 13 that I just talked about here a minute ago, I love it. And I love that it has a metal chassis because it makes it really durable, and I've really like that. But the problem to it is that it gets so hot. It's running a Core i7, and it just, I always have to put something on my lap if I'm going to use it. I can't actually set it on my legs, so I'm always grabbing a pillow or a laptop stand, and it almost needs a laptop cooler anymore. But so I think as we see Microsoft dig into ARM, I'm really excited to see where this goes because I really think that long term, I think you're going to see. Some really great improvements. I'm going to jump back over here to show one more thing because this is where I'm where I think we're heading, and this is what I was talking about a second ago. So in this power profiling, you see the Dell XPS 13, gets a great score, right? And so the Surface didn't quite score quite as well. I'm interested to see how the Galaxy Book 4, what that looks like. So I'm going to be watching some of this hardware pretty closely. Unfortunately, this is the bummer, is that we see then they fall behind in the GPU. Now, what I'm going to be really interested for, though, is that, and so you can see here, Apple's integrated GPUs are exception, right? Because they scale up and they do this massive 40-core GPU thing. And so it's pretty impressive what Apple's doing there. And they have the advantage of building, obviously this has been their claim to fame forever, is their ability to be able to build hardware specifically for their software, whereas all these others are, building for cross. But it's good to see Microsoft kind of building a little bit closer to it. And so these integrated GPUs, if you just do integrated, not the actual extra spin-ups, then it actually does pretty well. But that's kind of the downside, though, is that you really run into, Apple's adding all these extra stuff onto it. And that's okay, because I think Microsoft and some of these other hardware makers will start to catch up on that. But ultimately, I'm not a big gamer myself. The only thing I'm really doing is video processing, maybe some image editing. But again, all of that's pretty quick nowadays. Doing lots of compiling. And on this, we're seeing those multi-cores and how effective Visual Studio is on this is very good. The benchmarks on it are really excellent. And so ultimately, I think what we're seeing is a really exciting time to see Microsoft starting to play back into the hardware game. It's interesting. They've dabbled in it for years, and they've, I had one of the original Microsoft phones, and so I've been kind of a fanboy of Microsoft a bit, but I've really just had to be honest that they've lagged behind. So this is pretty exciting to see some really good, takes that they're taking on it. And so it'll be interesting as we, this shift could lead to a lot of innovation that we haven't even dreamed of yet. I'll be interested to start seeing more ARMs push into servers. I think that's going to make some server stuff, servers hitting on time. I'm getting some comments in here. So, the x86, and I've got a comment from Morgan here that says try to use ARM with crossover on a MacBook. I mean, look, I get it. I've been stuck on x86. I mean, like I said, I'm still on a 2021 Dell XPS 13 because that x86 performance hasn't been able to be matched. And I think we're finally starting to see a time where we can start to get close. I agree that performance on MacBooks with the M3 still isn't there compared to x86. Overall, when you just go grunt power, but that's the difference, is it's grunt power, and we're spending a lot on efficiencies to lose that grunt power. But thanks for the comment, Morgan. I really, truly appreciate that. The best compliment you can give me on these is to, come on and give me your thoughts. And so I'm interested to, because I agree with Morgan here. Ultimately, at the end of the day, x86 has been running circles around ARM for a long time. So I'm excited to start to maybe see some inkling that we're starting to see light on the horizon. Because I think ultimately, as we start to, move forward, I think we can see, some of these things to start to see some, at least a comparison to x86. x86 will probably stay on servers for a long time. I don't think ARM will take over. I'd like to see it. I would love to see innovation around that. But I think x86 will still win for that very reason. But I would like to see these ARMs start. I mean, it's been a dream for a long time to be able to see these ARMs start to catch up, these ARM processors. So what do you think? Do you agree? Do you disagree? Love having a good, healthy conversation. So make sure you leave a comment, even if it's after the fact, even if you're watching this live later, because I go back and I personally answer all of the comments. And so definitely, we'll go back, and I always make sure that I answer all the comments personally. So I love having great discussions. Here at StartupHakk, we love to train software developers in our coding boot camps and to build custom software solutions. So reach out. We'd love to help. Hit the links down below. Until next time, keep hacking and keep dreaming big. Thanks, y'all. Make sure you like and subscribe to the channel, because we bring you lots of great tutorials and tips that every developer should know. See you next time.